Hello everyone. My name is R.I.S.E and I am Head of Department of Robotics and Artificial Intelligence at the National University of Sciences and Technology, Pakistan. We are offering Masters and PhD degrees in Robotics and Intelligent Machine Engineering, and our department is basically a part of the School of Mechanical and Manufacturing Engineering of this university. However, the students we have are of a variety of backgrounds, which include electrical engineering, mechanical engineering, mechatronics engineering, computer sciences, and computer engineering, etc. I'm also heading as principal investigator the Laboratory of Robotics and Intelligent System Engineering, abbreviated as RISE. So at the RISE Lab, we're pursuing a number of projects of various domains, including humanoid robotics, cybernetics and bionics, rehabilitation robotics, and etc. A lot of other fields are there as well. So today we are going to show you through this video a glimpse of some of the projects that we are doing in this lab. You might be familiar with RoboCup competition, which is also known as the Robotics World Cup, and it's famous for its robot soccer competitions, which take place in various places. It takes place in a different country every year. RoboCup has several leagues, and its top league is played with humanoid robots. It's a standard platform league, which is played with now humanoid robots made by Aldebaran Robotics. So apart from walking on two legs, one of the obvious difficulties that it has is the full autonomy that the robot has to execute. It can't be connected with any computer on the outside. It can't be connected with every human that can guide the robot from the outside. So it must, play autonomously, perceive the environment, plan its motions, and play totally on its own. So it's cooperative and competitive artificial intelligence at the same time. I'm happy to tell you that it's the first and the only team from South Asia, from our lab, that has qualified for the International RoboCup competition. We are also working to design an interactive humanoid robot which can use not only the face expressions but also whole body gestures or whole body motions to try to convey various emotions that it is feeling at any given time. So its face is basically a normal mobile phone, and we are designing it to be a companion robot. So it can also access your apps and stuff, and it can do things like, for example, post a message on Facebook for you. We're also recently using humanoid robots for therapeutic applications, where we are making humanoid robots interact with autistic children. In other applications, we're working on designing an autonomous wheelchair. It has autonomous and semi-autonomous modes. It can sense the environment on its own. It can do simultaneous localization and mapping. It can be controlled using your mobile phone. You can install an app on your mobile phone and control it. We also have some advanced applications like controlling a wheelchair with your eyeballs movement. You can track your eyeball and the wheelchair can move according to it, and it can also be run using human electroencephalography, EEG. So right now, these systems are basically integrated, and sensors are able to steer the wheelchair, but we are working on the advanced applications of artificial intelligence to do semi-autonomous steering in complex obstacle-controlled environments. We are also working to design prosthetic hands and prosthetic feet as well, which will come later. So for prosthetic hands, as you can see, we are designing EMG based interface systems which can pick signals from under your skin and actually run various kinds of devices that can be used to operate these limbs. And we are in the process of designing mechanical limbs as well, which can be actually mounted on the human person who is amputated. So these are the prosthetic applications that we're working on. For prosthetic feet as well, we have developed recently a foot. We are in the experimental stages of this now. We've also developed a device for human brain imaging which works on the principle of functional near-infrared spectroscopy. Here you can see the signals from the subject's brain, which are being shown in resting state and also in the working state. We're also working to design several other kinds of robots, which include some legged robots, like this four-legged robot that you're seeing in the picture, and this other humanoid robot. It's a life-size humanoid robot that we're trying to build. And we have also recently started venturing into designing of wearable exoskeletons. So this is another exoskeleton we are designing for the arm of a person who's paralyzed. I hope you enjoyed the visit to RISE Lab. Looking forward to working with you.
Here's a bonus video clip showing the mobile robot Pioneer 3 AT moving around RISE Lab, carrying out simultaneous localization and mapping, and also conducting motion planning among obstacles in real time. So we have a whole fleet of these robots, and as you can see, the robot is equipped with LMS 200 laser rangefinder and also the stereoscopic camera mobile ranger, which is compatible with the Pioneer 380 mobile robots. So I hope that you like the research shown in this video and that you like the content, and I hope that you will like this video as well and do subscribe to my channel as well. Looking forward to keep connecting with you and keep sharing with you our research results. Thank you.